In FeatureCAM 2013 R2, a number of new options have been added for stock models. The first is Detect Material Thicker Than. This means FeatureCAM will ignore rest material thinner than a specified threshold value. This will help to avoid thin regions that have been caused by previous machining operations. This is especially useful when trying to cut a part, as we avoid areas where a second cut may be negligible. We can also control toolpath fragmentation using the new minimum gap length option. This replaces gaps shorter than a specified distance with a toolpath segment. In the case of this part, we have the headlamp mould, and you can see we've got a number of pre-created features. In this case, we have a Z-level roughing operation using a tip radius tool, and it's also got the unsafe area removal switched on. We have a parallel semi-finishing operation or semi-roughing operation, which leaves a small amount of material on the split faces. And we also have a Z-level rest roughing operation, in this case using the default settings. If I go ahead and play a 3D simulation, you can see we get our initial roughing. We can then get the cleanup pass on the split faces, and then we get our rest machining, like so. So from a 3D view this looks pretty good. However, if I stop my simulation and just view the toolpaths themselves, so I'm just going to fast forward just to display the toolpaths, and then go through each one in turn. So we have our initial roughing, we then have our parallel roughing, and then I have my Z-level rest roughing. So clearly you can see the tool is actually ridden onto the top of those split faces. So an option that we introduced was the ability to choose whereabouts in the stock model we wish to reference for our rest machining. If I go to the Z level, into the stock tab, you can see here under the operations I can choose multiple operations. In this case this was just referencing the first operation, the roughing. I've already added the parallel semi-rough to this operation, so I can start and machine from the stock model at this condition. Let's turn off the operations and just do a centerline calculation. We now get much more efficient trimming of the toolpath. Inside the model. However, we can see there is some fragmentation around the part, and we're also machining in these regions here. So if we look at the default settings of this toolpath, into the stock, you'll see we have a new button called Stock Model Options. Under the Stock Model Options, you can see we have three settings: Expand Area By, Detect Material Thicker Than, and Minimum Gap Length. The Detect Material Thicker Than will allow us to analyse and detect where we have large regions or excessive regions of stock material. We can then trim the toolpath to only machine the regions within this specified threshold. From this value we can also expand the area outwards using the Expand Area By option, and we can use this minimum gap length to control the distance between the fragmentation segments and create toolpath segments between them if we wish to do so. So by default we never used to have the control of these values, so we would always end up with 0, 0 and then a gap length which is related to the tool size. If I go ahead and select my second toolpath, so in this case I've gone ahead and changed some of the stock model options. So I've left the default expand area by. The minimum gap length in this case I've left at 0. But in this case I've just set the only value is the Detect Material Thicker Than. I've set this to 1.25 millimeters. If we go ahead and look at the roughing tab, we can see the finish allowance in this case is 1.25 millimeters. So I've set my Detect Material Thicker Than to the same value. If I go ahead and just calculate and view this toolpath, you can see we get very little machining of the part. So because we have an allowance already associated with this toolpath and we set a large Detect Material Thicker Than value, we'll get very, very small amounts of machining. So this is an inefficient way to use this particular parameter. Because we've already taken into account the size of our allowance value, we need to have a much smaller value for our detect material thicker than. So in this case you can see I've now dropped this value right down to 0.25 of a millimetre. So the key thing here is we'll see less machining of these areas around the outside, but we will see machining in the corner areas where the thickness of material is greater than 0.25 over our original allowance. I've also chosen to expand this area out so that the toolpath segments will be extended along those regions as well. But again, I've also dropped my minimum gap length down to 0. Again, if I go ahead and play the center line for this one, you can see we get much more machining within this operation. I can also see that we've cleared out the corners in these regions, all the way down the part. This will make for a much shorter toolpath length. I can verify this by going to the tool mapping, and in this case I'm going to select this tool, look at the tool life, and I can see this is travelling for 5,118 millimeters. This is creating a much more efficient roughing toolpath, as we are only removing the material in the corners and on the largest cusp regions. However, we do get quite a number of lifts on the toolpath. If I was to play this as part of my 3D simulation, I get my initial roughing operation, clearing of the split faces, and we can see get a lot less of the yellow passes on the component. However, if I wish to avoid the lifts, I can also choose a large gap length. In this case, if I go back to the stock tab, note I've got the same values for expand, area by and detect material thicker than, but in this case I've chosen a very large 200mm gap length. So any of those fragmented segments will be then filled with a toolpath segment up to a length of 200mm. Again, if I go ahead and play the centerline simulation, we can see those fragmented segments have been filled in, and we only get segments where we've got a full slice. You can see we've got a short segment here because there's no other segments to join. However, if I go ahead and again look at the tool mapping, look at the length of this toolpath, we've now got double the cut distance. This will keep the tool in contact with the material for longer though. Again, playing my 3D simulation, view our roughing, our split face machining, and then our rest machining inside the cavity. If we go back to the results area, just turn on the original and compare the two, you can see the difference in the toolpaths in comparison to the amount of fragmentation that's occurring.